Question 22. Which statement is true about the quadratic function g of x shown in the table and f of x equals the quantity x minus 3 squared plus 2? So our values in the table we can see, and the context of our answers, we've got three different categories here. We've got our zeros, which in this case, it's when y equals 0. And we don't even have a 0 from our table, so that doesn't really help us. We've got a vertex, which that's the turning point for our quadratic. So in the table, our turning point, our vertex, is 3, -5. That's the lowest point in our table. So that's where this thing changes direction. This 3, -5, the vertex has the axis of symmetry that goes through the vertex. So our axis of symmetry is also connected to the point 3, -5. So let's graph f of x and compare what we know. Home screen, new doc, say no to drugs, and add a graph page. So the quantity x minus 3 squared plus 2. Make sure, no matter how you ever get that squared, when you put the plus 2, you have to be back at the baseline, because if you don't, you're going to add 2 to your exponent, and it's going to change your function completely. So this is our graph. Now, if we do menu 5-3, set our trace step to 1, we can do a graph trace with menu 5-1 and see all the important points on our graph. So as I go over, if you notice, my minimum is 3, 2. So when we think about our axis of symmetry, the axis of symmetry goes through the vertex. So if I press tab, delete my equal sign, go to relation, I can graph the line x equals 3. And that is the axis of symmetry for the function f. Now, if we look at our table, if the vertex is 3, 5, this quadratic also has an axis of symmetry of x equals 3. Therefore, the answer to question number 22, both of these functions share the same axis of symmetry. They have a different vertex, but the x-coordinate of the vertex for both is 3.